Smart automation, better business. Learn how to optimize your business with Solved.
Switching gears here, jumping back into our business automation frameworks. This is a very super high level 3 steps to success with AI adoption. First thing, you want to make sure you've got a good strategy. Understand the outcomes that you're going for, how you're going to measure if AI is being implemented successfully or if there's ROI. Kind of lay that foundation, get on the same page as an executive team. From there, step 1 is not to start buying a bunch of tools and implementing a bunch of things, but rather giving your teams and your experts that work at your company access to tools and then encouraging their use so that those people can find little ways to improve the work that they do, find the little efficiencies, the time savings, and a lot of times through that process, the best places to put the money for the strategic initiatives sort of bubble to the top where they say, hey, we found a way to go faster. We could go even faster, sometimes significantly faster if we spent money to build a tool that did this or to buy this system. And so it can kind of reveal the best places to do the strategic initiatives. And then step 3, that's where we're at, top-down adoption. So this is now, once the use cases begin to become clear, what do you build or buy to implement AI holistically? Often, just as a quick recap from last week, well, actually here, let's jump in and do it this way. The things that you could implement, most tools and like services or projects that you might build are going to fall into one of 2 categories. There's workflows and then there's agents. So every organization is kind of composed up of, this is an oversimplification, but really like a business is a bunch of tasks that need to be done consistently. And so step 1 is kind of figuring out what those tasks are. In a traditional business, pre-AI, usually you would divide those tasks into different roles that are responsible for a number of tasks. And that kind of starts to, your business starts to take shape across those roles. Well, this is where the workflows and agents come in. We're familiar with automation. Automation has been around for, a good long time now. And then software has been making things more efficient, and workflows fall squarely in that automation category, where this is just AI has allowed us to automate more things. There's a few processes that maybe they need some intelligence or some creative writing, or not creative writing, just words need to be strung together in a way that describes something or makes sense. And that wasn't possible to do before with automation. But now there's a lot more things that can be automated because we have that. We can add in a step that consults an LLM or gets some intelligence for a decision that needs to be made or generates some words. And so anyways, that would be workflows. Agents are where you have an LLM based automation that can do many things and can make decisions and kind of operate autonomously. And this is where like whole parts of a role or an entire role could be done by an AI empowered system. So we talked about workflows last week. We're going to jump into agents today. Just as a quick refresher here, I'm going to switch and share this article. So last week we did a deep dive, so keep a high level this week, but there's a whole section at the end I want to make sure and get to. So building effective agents is an awesome article by the engineering team at Anthropic. So this came out a couple months ago, I guess. Yeah, been about 3 months. That breaks down the difference between agents, gives some advice on when to use them and when not to, and then talks about frameworks and workflows. So we talked about a bunch of different workflows that can be set up, and there's some great explanations here. Prompt chaining and routing, several others, until we get to this evaluator optimizer where things start to look more like an agent. Just a quick recap, this is when you have an LLM that generates something, and submits it basically to another LLM that evaluates that output and says, is it good enough yet? And if not, it's going to send it back. And then that's going to repeat until this evaluator says we're good to go. So this is where it starts to look more like an agent. And then the article goes into agents here. So this is really just the diagram I wanted to take a look at. What defines an agent is a system that's able to take in action that influences an environment and then measure that environment and see for itself, did we do the thing yet? Is the task accomplished? So a human might give an agent a task and then it's able to act, observe, and say, is the thing done yet? And then based on that observation, decide what are the next steps, what are the other things that might need to be done, and decide, basically build its own workflow, execute that thing until it can observe in the environment, hey, this is what the user asked for is done now, at which point it can stop, wait for the next task. So let's jump into kind of the anatomy of an agent and talk about just the goal here is to get a good framework for how, well, let's see what has happened to my presentation. Okay. Your goal here is to get a good framework for how to think about agents and kind of conceptualize them. So what there is, it's maybe something we edit out for the recording. There's just weird. Okay, there we go. That's correct. I had some kind of margin that was getting added on my screen share here. So, all right, that's better. Okay, so jumping back in, goal here is to figure out how to use. Okay, let's take it again. All right, so the main goal here is to basically be able to conceptualize agents a little bit better, understand what they need, the building blocks of them. I think people assume AI agents are really complex, and there's some complexity, there's some steps, but ultimately they're a lot simpler than I think a lot of people realize. So an agent essentially is composed of three main building blocks. So you have the AI, which is going to be an LLM, GPT-4, Claude 3.7, whatever it is that you're using, that provides sort of the brain or the reasoning or the intelligence of the agent. And then you've got context, and that can be given a number of ways. We're going to dive into it, but it's stuff that you're feeding the AI to say, okay, here's all the context. This is what I'm asking you for. This is what I want you to do. This is what you can do. So you're feeding all of that to the AI. And then you're also giving it a list of tools that it can choose to execute, which are going to do actual things. So the limitation with AI right now is, well, really the main, how it works is it's text in and it's text out. So it's going to analyze a bunch of text, and then all it can really give you is text, right? These things they're not embodied. They're not like a persistent entity that exists in a computer. It's a very large math problem. Takes words on one side and then words come out the other side. So you need to find some way to turn that output into the AI can use words to choose to execute some tools that you've built for it. And then those tools work, and it can maybe configure the tools or add some context to say, this is what I want the tool to do. So essentially the tools are, just giving the AI the ability to act. A robot body would be considered a tool in this framework. The agent of a humanoid robot would be the AI as the brain, and then a bunch of tools that the AI has access to, including like, hey, use your hand to go pick up that thing. And then the tools have, anyways, so you can have nested agents communicating with agents that are operating the different parts of the robot, and it all gets complex at that level. But it's one good way to think about it is the tools are sort of the hands and the body of the robot. Breaking this down just a little bit further, let's talk about when choosing an AI, you're thinking about price and performance. And that's going to change based on what you want that agent to do. So for some things, it's a pretty simple query. Maybe it's just question and answer, it's a chatbot or something, and it doesn't need to know that much. You can use some pretty inexpensive models to figure out, you got to figure out what level of performance you're looking for, evaluate your options, and use one to keep your costs down. There's some very expensive models that can do some impressive things. A lot of tasks aren't going to need that level of intelligence. So one place that I will refer you to that I would like when it comes to comparing models is Vellum AI. So Vellum is an AI platform for like AI adoption at a company. So it's kind of like an enterprise platform for AI. They offer some pretty cool stuff. Not going into that at this point. They, on their website, have some leaderboards that say, for the task, reasoning, coding, math, what are the best performing models? What are the fastest models? What are the most affordable models? And then you can do direct comparison, including costs. So you can see Claude 3 Opus versus GPT-4. You can see the different costs of them, and then their performance on some of the main kind of benchmarks. And then there's a more in-depth table of benchmark performance and a leaderboard for AI. So anyways, pretty cool resources there. So jumping back into context, once you've decided the AI that you need, what context are you providing? So the system prompt is basically the part of the context that says, this is what you are as an agent. This is what your goals are. This is how you should behave. So you're giving the agent sort of a, for lack of a better word, a personality and an objective with the system prompt. You can have some user interaction. If you have a chat interface or some way to give, for a person to give instructions to the agent, that's going to be your user interaction. There's dynamic context. So in the example we're going to get to in a second, customer service, if somebody's calling in and they need help with a certain product, dynamic context might be information about that product. Today's date, right? If you're injecting this is today's date, that's context that might change depending on what day it is. What are they asking about? Who is it that I'm talking to? That's going to be your dynamic context. Tool definitions, you're going to give it a library of tools that it can use, and so it knows what it can even do. And memory. So all of this context that you're feeding into the AI, and then all of the information back and forth between the user and the agent, if there is a human involved here, all of that's going to get stored as the agent is doing a certain task. It's also going to store, you want it to store the actions that it's already taken, the result of that, all of that starts to load up the memory. Right now, that memory goes into what's called a context window, and those are limited. One of the things that AI companies are racing each other on is who can get the biggest context window. So right now, Google has a model that I think has 1 million token context window. Token is kind of like a word. And one word probably equals an average of 1.5 tokens. So anyways, that they compete with each other on how big can we get that token or that context window. And that's the memory. Beyond that, you'll have tools that are usually code. It's just code that's been written or some way to do a thing. And it's important that tools have descriptions. So when you're listing out tools in your tool definitions, you say, hey, this is a tool that does this thing. Use it if you want to get this thing done, right? And so you have a good definition for it. Example would be web search. So this is a tool that does a search. So if you give me something to search, I'm basically going to pop that into Google essentially, and then return the search results to you, or summarize the search results and return it to you. You want all of that in the definition. So let's take a look at an example here. Customer service triage agent. So if you had somebody that's sort of the first line when an email from a customer comes in, maybe you can resolve that person's concern very quickly using an agent, almost instantly, give 24-hour support and have this thing just sort of sitting there, taking care of the easy questions or easy cases to resolve, and then knowing when it needs to kick it over to a human expert. So that's the example here. So I put GPT-4o on here just because it's a commonly used model. I'm not necessarily saying it's the best for customer service inquiries or things. The right idea would be to figure out what you need in terms of intelligence, price it out, and likely do some science, do some experimenting to figure out which models are giving me the right kind of output that I want. So context for this, you might put a system prompt. This is very simple, but you might say something like you're an agent who answers customer questions via email and creates cases when technical support is required. A user interaction might be an email that arrives and says, hey, my computer's been running really slowly. In this instance, in this example, we're a computer company. Dynamic context could be when the customer emails, we're searching our CRM to say, what details do we have on this customer? And here's their purchase history. So now our agent kind of knows who this person is that they're talking to. Tool definitions, we're going to say you have access to a search knowledge base tool, send email, update case details, and escalate case. So those are the things that you can do. And then we're going to send all of that to the AI. It's going to get stored in our memory. And then all of the emails back and forth and all the actions that it does, those are all going to get loaded up in memory as they happen. And when I keep saying in memory, I want to clarify, I'm talking about the context window that the AI has to work with. If we max that out, we're going to have to start purging from the back or selectively purging things to fit this interaction into a memory. So anyways, it's getting really technical. Maybe we'll come back to that another time. There's just something to know, they're finite. I think that's my point here, is that these aren't infinitely big. So in our instance, we get an email that says my computer's been running slowly. First thing, it might choose to search the knowledge base and say, when this computer, I know what they've purchased because I've got the dynamic context. When those computers run slowly, what could be the issue? And the knowledge base might have a list of steps to try. And we might send that knowledge article or summarize the knowledge article for the piece that they need. So we might then send, the agent might say, I'm going to use my send email action or tool to send them an email and say, have you tried turning it off and turning it back on, right? Or try these things, let me know if those don't work. And maybe our user tries those things and says, yeah, I turned it off, turned it back on. It's still running super slow. Can you help? And at that point, it might decide based on, if we put in more detailed system prompt, we might want to say, hey, at this point, if you've emailed once or twice, or you're sensing that they're getting upset or something like that, then it's time to escalate. And so what the agent could do is update the case details in your CRM or your service software and say, all right, this is their original email. These are the things that I told them to do. Here's what they tried. This is what they responded with. Basically, we're taking all that information, maybe some links to knowledge base articles that might help, popping that in the case details, and then we're going to escalate the case. And that could mean just assigning it to somebody else, like a human, to take a look at. And then that agent can just sort of sit there and do that. And as long as it's configured correctly, provide a better customer experience, a faster customer experience, save your agent's time for things that are more complicated the AI can't handle, and you just get more efficiency across the board, while hopefully making your customers happy. Big, huge asterisk here, big disclaimer. Customer-facing AI applications, you're taking a risk. You really want to do a lot of good testing, because what's really frustrating as a consumer or as a customer is when you're talking to a robot and then that robot's not helpful. I think a lot of people don't mind talking to a robot as long as they're getting what they need. But if they can tell they're just getting generic answers, things that aren't helping, then there's a good chance they're just going to try and figure out, whether it's in a chat interface or on the phone or through email, like, how do I talk to a real person? Just give me a real person on the phone. So you don't want to provide that kind of an experience if you can avoid it, but there's certainly room for iterating and testing and working on something like this. And there are companies that are using this to great success and increasing their bounce rate by quite a bit. Customer satisfaction increases. So anyway, it can be done, and it should be done correctly. So anyway, something to keep in mind. Okay, so with that said, before we move into Q&A, I just wanted to show you or talk about like some good principles to keep in mind when building agents, and then how to build these. So great, we've got an architecture now, but like, how do you actually make this real? Start, using agents, buying agents, building agents. How does that work? So first, I'm going to jump back to our Anthropic article here and talk about some best practices. Again, can't recommend this article enough for some more information. They've got some examples down here, including customer support, coding agents, but there's sort of these 3 best practices to keep in mind and core principles that they've found success with. So 1 is maintaining simplicity in the agent's design. 2 would be prioritizing transparency by showing the agent's planning steps. And then carefully craft your agent computer interface through thorough tool documentation and testing. So simplicity is important because there's only a certain level of complexity before these agents start to have a hard time. If they have hundreds of tools to choose from, it becomes difficult to choose the correct tool. And so you want to keep agents pretty single purpose. And maybe, I guess, single purpose isn't quite the right word or phrase. You want to keep them small if possible. Often you can get more success out of several agents that do a set number of things really well that can invoke each other. They can talk to each other. You say that, I'm an agent that does this. There is an agent that does this. I'm going to kick this over to them. And then, so you can find more success with that than like one monolithic agent that you try to make able to do everything. So keep it simple. Transparency is important because you want to see the plan before the execution. You want to be able to keep a human in a loop and have that human understand what's going on so that you can correct or course correct, keep the agent on track. And then for just debugging, if you know what its reasoning steps are, you can understand why it might be doing some of the things it's doing and kind of improve on that. And then documentation and testing, you'll just basically saying, build good tools, build tools that work, test your tools, have right tests for your tools, make sure they continue to work, and then document them. That's helpful for people as well as for the AI. A well-documented tool with a good description, an AI is going to be better able to use or identify that it needs to be used. So some things to keep in mind. The fact is, we are quickly moving into an era where business is more and more automated, and it's not even fully clear yet exactly how that's going to look. But there's a lot of possibilities today. At Solved, we're implementing them more and more all the time and automating more and more of our business. And it's really exciting. I want to help you do the same. So feel free to reach out. And that's all. Thanks, everybody.
Thank you so much for watching. We can't wait to help you automate your business. Please like, comment, or subscribe for more.